Hello to all our listeners out there. Welcome to our Hordes Dairyman monthly webinar. My name is Abby Bauer, and I will serve as the host for today's program, which will focus on reproductive technologies. Improved reproductive performance in lactating cows has allowed for the use of reproductive technologies such as sexed and beef semen and IVF beef embryos. This presentation will overview the results of two recent studies that evaluated these technologies in lactating Jersey cows. If you're listening to our presentation live, you have access to a PDF copy of the slides. Just go to the handout section of the control panel and you'll see a link there where you can click on that and save or print that PDF. In addition, if you have any questions for our speaker while you're listening in today, please type those into the questions section of the control panel and we will answer those following the presentation. Our sponsor for today's webinar is Cryoport Systems, and we thank them greatly for their support. Today, it is my honor to welcome Dr. Paul Fricke as our webinar speaker. Dr. Fricke is a professor of dairy science at the University of Wisconsin-Madison. He was raised on his family's row crop and dairy farm near Papillion, Nebraska, where his father continues to farm today. After receiving his bachelor's degree in animal science at the University of Nebraska, he went on to complete a master's and PhD at North Dakota State University. He joined the faculty at the University of Wisconsin-Madison in 1998. His current position includes both research and extension responsibilities in the area of dairy cattle reproduction. His research focuses on understanding the biology underlying the many reproductive problems of dairy cattle. Paul has authored or co-authored many journal publications, abstracts, and book chapters. He has mentored 16 master's students and 6 PhD students, and his research program has attracted $4.5 million in grants, contracts, and gifts. Dr. Fricke has spoken to audiences in Wisconsin and then all over the world in 36 different US states, 6 Canadian provinces, and 20 different meetings in 28 countries and on 6 continents around the world. So we are so glad to have you here with us to speak to our audience today on some of your new research. So welcome, Dr. Fricke, to the webinar, and I look forward to hearing your presentation, which is titled, Where's the Beef? Exploring the Use of Sexed Semen, Beef Semen, and Beef Embryos.
All right. Thank you so much, Abby. It's always a lot of fun to be invited to do the Hordes Dairyman webinar. Really enjoy these. So thank you for that introduction. And okay, here we go. So where's the beef? So where did I get that title? Those of you who are old enough might remember these Wendy's commercials where the old lady here was asking where's the beef? But obviously these are some technologies that are used now more heavily in the dairy industry than they had been probably 10 years ago: sexed semen, beef semen, and IVF beef embryos. And so what I want to do today in this webinar is I'll go through a little bit of a background on sexed semen and beef semen on dairy cows. There's actually 3 studies I want to talk about. The first one is just a characterization study, kind of see what's happening, how farmers are allocating sexed and beef semen and Holstein and Jersey females in the US. The second study, optimizing use of sexed and beef semen in lactating Jersey cows. And the third is evaluation of the effect of HCG on pregnancy outcomes in lactating Jersey cows receiving IVF beef embryos, IVP beef embryos. Okay, so I'm going to start here as far as a background is concerned. This is a study that was recently published by a group in Ireland. The main author here, Dr. Butler, I actually did my sabbatical with Dr. Butler in Southern Ireland in 2014. So they recently published a very interesting study, randomized controlled study, where they had Irish Frisian Holstein cows in Ireland, and they randomized them to be inseminated with semen, and then they had 2 treatments with sexed semen. They were looking at a difference in timing of insemination here. There's no difference due to that particular treatment, so I'll kind of talk about those together. Good numbers of animals in this study. When they inseminated these cows with conventional semen, 61% conception rate in those animals, and they had 49% and 51% in these 2 groups of animals that got sexed semen. So just to summarize this, and this is a point I want to make, Fertility of sex semen is about 80 to 85% that of conventional semen. And this is not necessarily a bad thing. It is what it is, but we have to realize that there's a little bit of a fertility drag. Some studies are a little better than this, but 80 to 85%, I probably use 85% more often than not, is kind of what I consider normal fertility with regard to conventional semen when we're talking about sex semen. Because of this drag on fertility, initially, sex semen was only recommended for use in non-lactating dairy heifers. And you'll see, most of you out there know this, but there's a lot of sex semen now being used in lactating dairy cows. So why sex semen? Why are we using sex semen now in lactating dairy cows? And I think this is a concept that most people miss when I hear presentations on sex semen. Everybody knows that we're using more sex semen, but I'm interested in why that is the case. This is some data from the Council on Dairy Cattle Breeding. So if you look at the phenotypic trend in days open, what you can see is from 1955 to the year 2000, the phenotypic trend for days open is to increase. So we're going from lower days open to higher days open. This is an indication that fertility is actually decreasing, or reproductive performance, I should say, is actually decreasing across this very long time period. In fact, that was the talk about the dairy cows, that we have, problems with fertility in lactating dairy cows. In the year 2000, that trend just reversed itself. And so today we're seeing an ever increasing improvement in reproductive performance. Now that's due to a couple different things. We've been able to increase the service rate in our lactating dairy herds, use of timed AI programs, the off-sync protocol developed in 1995. We also have automated activity monitoring systems, which help us put semen into cows by catching those cows with increased activity. So part of this increase is, and a big part of it is just that we've increased our ability to put semen into cows, which of course is the first step to getting them pregnant. The thing that really surprised us when we started looking at these data, and I anticipated this would happen. If you look at the long-term trend for conception rates in lactating dairy cows, they were mid 30% range. And I usually challenge the older people in my audiences, if they've been in the industry for a number of years, this was kind of normal for lactating dairy cows. That situation has dramatically changed, particularly in about the last 10 years. We've seen dramatic increases in the cow conception rate. This is the phenotypic trend in cow conception rate. If you would have asked me 20, 25 years ago if we'd been able to do this, I probably would have been very skeptical, but it actually happened. So most herds are looking at close to 50% conception rates in lactating dairy cows. Why has that happened, this increased fertility? Use of fertility programs like double OBSYNC, which I'll talk about a little bit. This concept that we call the high fertility cycle. I think I've done a Hordes Dairyman webinar on the high fertility cycle, this concept. And of course, there's been genetic selection for fertility across this time. So we've been very successful at turning around the poor reproduction in lactating dairy cows. And I want you to keep in mind this last 10-year period, because I'll show it on some of these other graphs. 2015 really to 2025, 2024. This is the period that we've seen this big increase in fertility. So this is some data that we got from AgSource, and I like this little data set because 2006 was when sex semen was first marketed. And if you look at breedings in Holstein females, used to be cows and heifers, you can see that for a long time, there wasn't much sex semen being used, and most of it was being used in heifers. In this last 10-year time frame, everything changed. Now, this is a stacked bar graph, so that the green part of these bars is the percent of Holstein sex semen being used, and then this blue part of the graph is the increase in beef semen on Holsteins, and of course, this red part is Holstein conventional semen. So really what triggered this change, and this is just a management change you can just see very clearly in this graph, increased use of beef semen, increased use of sex semen, and much of that in our lactating dairy cows. If you compare that with the Jerseys, Jersey folks have been using more sex semen, most likely because the value of a Jersey bull calf is extremely low. And then again, this period when we saw increased fertility, we started to see dramatic increases in beef on Jerseys as well as sex semen on Jerseys. So that's kind of the long-term trend, and I just wanted to link that with kind of this time period with the increased fertility. So I think the reason we're able to use more sexed and beef semen on lactating dairy cows is because the increase in fertility that we've seen in these lactating dairy cows. So this is just, I pulled this out of Horde. So Abby wrote this up on April 15th. This is just showing the trend in the use units sold domestic beef semen sales. Again, look at that time frame. This is concurrent with that increased fertility that we've seen in the lactating dairy cows. Of the 9.4 million units of beef semen sold domestically in 2023, 7.9 million units were used in dairy herds. That's up nearly 1 million units from the year before. So more beef semen is being used on dairy cows, and obviously we're getting quite a bit of money for those crossbred beef dairy calves, but it's not all positive. This is U.S. heifer inventory from the USDA, and you can see what happened concurrent with the increased fertility that we saw more and more replacements being generated. And then about in 2016, when you see this trend for the change in use of sexed and beef semen, we're seeing this heifer inventory decreasing. That's had a tremendous impact on replacement heifer inventory, as well as the value of those replacement heifers. Really high replacement levels, dollars for some of these replacement animals compared to what we used to see. And so there are some negative consequences of using beef semen, and particularly in using too much beef semen, which I think some of the trends would show us that might be happening. Okay, so that gets us to our first poll question number 1. And here's the question. Are you currently using sexed semen to inseminate lactating dairy cows in your herd? So I'm not interested in the heifers. I'm interested in the lactating dairy cows. And so very simple, it's A is yes and B is no. So Abby, let's do the poll.
All right, you audience members, you can answer this question. Very straightforward, yes or no. Are you using sexed semen in lactating cows? We've got good response rates. People are answering. We will close the poll.
I think the number's going to be high.
Yes.
That's my guess.
So we have 71% of people say yes, 29% no.
Okay. Yeah, I was going to say about 80%. That's what I would have expected. But just goes to show, Abby, that we are seeing dramatic increases in use of sexed semen in our lactating dairy cows. And again, I'm going to argue that that's because we've been able to improve the fertility of these lactating dairy cows. So that's why we've seen that. Okay. All right, so now I'm going to get into the first of the 3 studies that I talked about. This is a large study that we did. DRMS gave us a very large data set. Most of the observations are coming from these states in the upper Midwest and the Northeast that are pink. So you can see New York, Wisconsin, Pennsylvania, Michigan, and Minnesota. I think that represents at least 65% of the data. There's some smatterings in other states as well, but that's where the majority of this data is coming from. So the way that this was done is we had data from the National Association of Animal Breeders. And so if you have a lactating Holstein cow, she could be inseminated to a Holstein sire using either conventional or sexed semen. And you can just tell this by the code on the straw semen, okay? You could also choose to crossbreed that Holstein with one of the 6 other U.S. dairy breeds, or you could choose to breed that animal with a beef sire. And this pie chart that you see on the right are just the different sires that are used on Holsteins in this data set. So in blue, over 55%, we have Angus, 14% Limousine, 12% Simmental, 11% crossbred, and 2% Japanese Kobe beef. And so those are just sires, at least in our part of the country, part of the country that I live in, those are the sires that are being used on Holsteins. And so what we did is we put together these graphs. They're a little bit complicated. It's a stacked bar graph. We'll start with that. So the red part of the bars is beef semen. The light blue is Holstein conventional. The medium blue is Holstein sexed. And you can't hardly see, there's not a lot of crossbreeding going on here with other dairy, the dark blue. The first row here are virgin heifers. The second row are first lactation cows. The next one are the second lactation cows, and these are the 3+ lactation cows. And we have this blocked by service number, first, second, and third plus service. And then the columns are the year, 2019, 2020, and 2021. And so if I'm doing this talk live, I usually ask the audience, people in the audience, to kind of tell me what they see. I'll just point out the trends. Sex semen use is highest in the younger animals and decreases as you get to older animals. And of course, anything you say about sex semen, the opposite is true with beef. So the older animals, more beef. As you get younger, less beef. More sex semen is used at earlier services, first service. More beef semen is used at third plus services. And then you'll also see, maybe a little harder to see in this graph, at this particular time in these particular years, the use of beef semen and sex semen is increasing. And again, this is a fairly large data set, 8.2 million insemination records from 3 million Holstein females and over 9,000 herds. So that's just what's happening. I think we caught this kind of at this transition phase when we've seen this, these dramatic increases in use of both beef and sexed semen. We took that same data and we just put it by herd size. So it's the exact same data set, but now on the x-axis, we're just looking at small farms less than 100 to large farms greater than 1,000 cows. And this really kind of surprised me when this cropped up. It's just a linear relationship by herd size. So you can see sex semen use goes up dramatically as herd size increases, as does beef semen. Now, from a data set like this, we don't know why that's the case, but it could be, one of the factors is that larger herds have better reproductive performance than smaller herds. They might be tending to want to use more sex and more beef semen in that particular case. It could be that larger farms are able to market those animals a little better than smaller farms. There's a whole host of reasons why we might see this. Okay, we did the same thing with these jerseys. So I'll run through this rather quickly because it's really kind of the same story. You could breed a Jersey cow to a Jersey sire using conventional or sex. You could crossbreed that Jersey, or you could use beef. The top 4 breeds are the same as in the Holstein. The proportions are just a little bit different. And so that's kind of what we have going on in Jerseys. Now, if you look at these stacked bar graphs, again, the turquoise is the beef, and then the browns are the conventional Jersey sex and other dairy. If you compare the two graphs, the Holstein and the Jersey, more sex semen being used in Jerseys, some crossbreeding popping up here in these Jersey herds, and less beef semen. I think the beef on Jersey calf is probably not quite as valuable as a Holstein, as a beef on Holstein calf. So more sex semen being used in these Jerseys, and of course not quite as many Jerseys as we had Holsteins in the other study. And we ran this out by herd size as well, and you can see it's these larger farms then that are using some of these crossbreeding strategies, Jerseys crossbred with other dairy breeds. So just kind of an interesting snapshot again to see what's happening in the U.S. with the use of sexed and beef semen in Jerseys and Holsteins. So just some take-home messages from this first study. Sex semen yields conception rates about 85% that of conventional semen. Okay, so you're going to have a little bit of a drag. Again, that's not a bad thing. It's just something we need to be aware of. Use of sex and beef semen has dramatically increased over the past decade, concurrent with the increase in conception rates in lactating dairy cows. And I think that's the increase in fertility is probably the reason that people are willing to use more sex semen in the lactating cows. Farmers allocate sex semen to younger animals at earlier services to optimize fertility and genetic progress. I think that wasn't a surprise. Larger farms use more sex semen and beef semen than smaller farms, perhaps due to differences in reproductive performance and economies of scale. We'd like to come back and look at this data now. I think that things have probably kind of evened out. We kind of caught this snapshot at a time when things were changing across the 2020, 21, and 22. All right, so that gives me to the second study. And this is a study that we were working with the Jersey herd here in Wisconsin. And remember that I said we have a drag on fertility with sexed semen. So we're just looking at a way to optimize use of sexed Jersey semen and conventional beef semen in a Jersey herd. Why Jerseys? Well, Jerseys are using a lot of sexed semen. We were really interested in these treatments that we were going to look at and the effect on fertility with sexed semen. So just as some background on this study, one of the hypotheses for why we see poor fertility in these high-producing dairy cows has to do with this liver metabolism hypothesis that my colleague Mila Wiltbank published back in 2002. So the thing that allows a cow to produce a lot of milk is that she eats a lot of feed. And so high feed intake is highly correlated with milk production. In other words, you can't really have a high producing dairy cow that doesn't eat a lot. Those two things really go together. When a cow has high feed intake, she will divert peripheral blood flow to the liver. And so liver blood flow increases and the liver is able to metabolize ovarian steroids. And so we end up with a cow with decreased circulating estrogen and progesterone concentrations. So this is what we would call a scientific hypothesis. When you set something up like this, you can test that hypothesis, which we have in many, many different studies at the University of Wisconsin and others around the country and around the world. But this is an interesting idea. If the problem with the high-producing dairy cow is that she has decreased circulating levels of estrogen and progesterone concentrations, can we affect fertility by getting progesterone back up where it needs to be? And so I just pulled this from a review paper, a symposium paper talk that I gave. My co-author, Mila Wiltbank, helped me with this. This is just a cartoon of what's happening at the end of an estrus cycle. And we're going to look at a non-lactating heifer, so no liver metabolism problem. She's not lactating. So what happens at the end of the cycle is this is representative of a follicle that's going to grow up and it's going to ovulate. When that follicle grows up, you can see estrogen concentrations increase after progesterone concentrations have decreased. LH pulses from the anterior pituitary drive the growth of this follicle. We get then estradiol will come to a peak. We elicit an LH surge, which causes ovulation. And in a non-lactating heifer, we get ovulation of about a 15 millimeter follicle. So this is kind of what I would call the wild type or normal physiology. And what happens to the lactating dairy cow, which I'm going to show, I'm going to contrast that, is that what happens is because estradiol is being metabolized by the liver, it rises more slowly. And so to get to a peak threshold that would elicit an LH surge, this dominant follicle in the high-producing cow has to grow a little bit larger and a little bit longer. And in fact, we've taken average cycle length in a heifer of 21 days and extended that to about 22.5 days in these high-producing dairy cows. And so overexposure to these LH pulses, we think, causes premature oocyte ovulation, ovulation of aged oocyte. We get increased double ovulations in twinning, and we ovulate a much larger follicle. So we think this is the impact that that is happening in these high-producing dairy cows with this liver metabolism. Now, that's the bad news, I guess I would say. The good news is we can do something about it. And we can do something about it with what we call fertility programs. And so this is a study that we did where we randomized cows. These are Holstein lactating cows in a dairy herd. The top protocol is the double ovsync protocol. That's what we would call our fertility program. The bottom protocol simply brought those cows into estrus at about the same day in milk range. And so we could breed those animals and compare the fertility. And what you can see is that if you breed these high-producing Holstein cows to estrus, you get about a 39% conception rate. If you breed them to a fertility program, we're able to increase conception rates by about 10 percentage points, which is quite a lot in a lactating dairy cow. So this is one of the factors responsible for the increased fertility that we're seeing. these fertility programs like double OVSync are indeed fertility programs. So that's half the story. We can increase fertility, but with a protocol like a double OVSync protocol, we breed 100% of the cows. We were only able to catch 78% of these cows in estrus. So if you do the math, the percentage of pregnant cows at 110 days in milk is about half the cows if you are more aggressive up front with a fertility program versus a estrus type program, which only has 30% of the cows pregnant. So we had done this work, and this was all done with conventional semen. And so we went to this Jersey herd that was using conventional beef semen and sexed Jersey semen. So they were only using those two types of semen. And so we randomized cows within a treatment. So we had a double OVSync protocol, just like I showed you before. We had this estrus synchronization program. Okay, so we randomized the cows within a semen type to these two different treatments. So these are just the numbers. Animals, beef semen, double OVSync versus estrus detection, sex semen, double OVSync versus estrus detection. Pretty good sized study, 1,286 cows. It's really two separate experiments, so I'll show them separately. The effect of double OVSync versus estrus when these animals were bred with conventional beef semen, and the effect of these treatments when they were bred with sex semen. And I just want to point out, the decision to inseminate cows with sex versus beef semen was made by the farm. I would love to do a randomized controlled study with semen type, but no one's probably going to let me do that particular study, so we did it this way. All right, so let's start with percentage of cows that we enrolled that were actually inseminated by semen type. You can see with both sexed and beef semen, you breed 100% of the cows when you put them on a timed AI program. People ask me all the time, if I'm watching cows for heat or I buy a activity monitoring system, what proportion of cows would I expect to catch in estrus? It's always about 75%, at 70 to 80%. We got right on 70%, both types of semen. So you're plus 25% percentage points on just the percentage of cows that you inseminate. So advantage here to double OVSync. When we looked at the effect of these treatments on fertility, this is with beef semen. So this is the preg check that was done at 34 days, the left-hand bars. These two middle bars is the pregnancy recheck. You can see double OVSync. We were hitting 60% conception rates with beef semen on these jerseys at 34 days, 57% at 62 days. That's +9 and +8 percentage points compared to the animals that were inseminated to estrus. So not only do you breed more animals with the double OVSync program, 100% versus 75%, we get much higher fertility with beef semen. Now, our hypothesis with the sex semen was that I was anticipating the difference to be even greater with sex semen. It wasn't for whatever reason, but it was still tending to statistical significance, +6 percentage points on conception rate with sex semen, 52% conception rate. If you take 85% of 60%, which it was with beef, you'll get 52, so that makes sense. And then 49%, so we're +6 percentage points. You're going to get an advantage there. Again, so we've got a product, sex semen, that has a little bit of a fertility drag. We can improve that by breeding these animals at first service with a fertility program. So just to summarize this study on timed AI versus estrus in jerseys, double OVSync and timed AI yielded a greater insemination rate at first AI than after synchronized estrus. It was 100% for double OVSync versus 75% for the cows that had a synchronized estrus. And then double OVSync and timed AI yielded more pregnancies per AI at first service than AI after synchronized estrus, +8 percentage points for conventional beef semen on Jersey cows, +6 percentage points for sex Jersey semen on Jersey cows. So we concluded that if you're using sex and beef semen on jerseys, it makes a lot of sense to set them up for first service on a fertility program. All right, so that's going to bring us to poll question number 2. And Abby, I'm really interested in the answer to this. I would say that use of IVF embryos or IVP embryos is increasing. So let's just see. Are you currently transferring IVP embryos into lactating dairy cows? Yes or no?
All right, looks like many of you have already jumped on and entered your answer. We'll give you a few more seconds, but
I
please
think this
click
is
yes.
going to be a low number, Abby. It's going to be a low
Okay,
number.
kind of flipped from the last one. So
It's probably going to be flipped. Maybe I'll guess 20%.
okay, well, we will close the poll and the answers will pop up here. So you're pretty close. Yes was 28%, no
28.
72.
Okay, I was off by 8%. Pretty good guess though. That's what I would guess. I would say that IVP embryo transfer is gaining a lot of ground, but it's a much newer technology and starting to penetrate the dairy industry, but interesting nonetheless from a poll question. So let's get into this topic of embryo transfer. These are some data from the International Embryo Technology Society, going clear back to 2002 up to 2021. It's a stacked bar graph, and there's 4 different types of embryos here. And here's the terminology. IVP stands for in vitro produced. So these would be derived from ovum pickup and then in vitro fertilization. IVD embryos are in vivo derived. So you're going to superovulate a donor, you're going to breed her, and then flush embryos. And so you can see we could have either fresh or frozen within either type of these 2 types, IVP versus IVD embryos. And so what you can see, this is just a stack bar graph. So it's not showing the increase in use of embryo transfer. I didn't show that graph. So it is increasing across time. This is just how they kind of break out. And what you'll notice here, again, that magic year, about 10 years ago, 2015, 2016, we started to see a pretty major shift with an increase in these IVP frozen embryos. And frozen embryos bring a lot of advantages because one of the biggest challenges with embryo transfer is you have to synchronize recipients. You have to get that synchronized with the number of embryos that you have to transfer. So a lot of cost and inefficiency comes when those 2 numbers don't meet. If you have frozen embryos, you can just thaw the embryos you need based on the synchronized recipients that you have. So there's a lot of demand, I think, for these IVP frozen embryos out in the industry. Now, there's a couple problems with IVP embryos. This is a figure that my colleague Mila Wiltbank put together. So if you start out with a fertilized oocyte and you just go through the first 60 days of gestation, if you look at the rate of pregnancy loss, let's say you breed cows to a double OVSync protocol, you can see where the losses occur, 15 to 50% here very early. And then you can see 10% from day 7 to 20, 20% from 20 to 27. So there's an awful lot of pregnancy loss that's happening in the first 27 days, a little bit more going up here to day 32 and day 60. Now let's compare that with pregnancy losses after in vitro produced embryos were transferred. And these are transfers into heifers. And just compare this brown number with the green one, and you can see threefold, more than threefold increased loss here in this period, 8% percentage points more loss here. And then the losses are very similar after day 27. So there seems like there's just a lot of pregnancy loss. So it's a big problem that we have with these in vitro produced embryos. I pulled this study. This is another very nice study by Dr. Butler in Ireland. They're doing just some great work over there. And what they did is they had these Irish Frisian animals that were bred, they were inseminated. That's the blue bar. When you transfer fresh embryos, you're going to get an improvement in that first conception rate on day 32. That's because you're putting a live embryo in, okay? And so you get an increase there. The beef fresh, look at the comparison though with the dairy, the frozen embryos. you're actually going to get a decrease in fertility. So the frozen embryos, it's kind of like freezing and thawing semen. You know, you have to freeze double the number of sperm that you want post-thaw motility on, and so you're going to lose some. So freezing is hard on these embryos, and you can see by day 62 the same trend. And here's the pregnancy loss. You can see that it's almost 20% in these frozen embryos, maybe a little bit less in the fresh embryos. I don't know why it was so low in the dairy fresh embryos, but just a very interesting, very large data set from some of the stuff that's going on in Ireland. And I would say Ireland, a lot of the trends in their dairy industry are mirroring what we're seeing here in the US. So we've done a couple studies with IVP embryos. This was a study we did in heifers, Holstein heifers, and we were transferring IVP fresh embryos of various grades, grade 1, 2, or 3 embryos. But keep in mind, these are fresh embryos. And what we did in this study is we synchronized these heifers with a 5-day cedar sync protocol. So we used a full protocol. You don't have to do that. Some more recent studies would suggest you could do a more simplified program, but we used a full 5-day cedar sync program. We considered the last gene or H to be day 0, and then 7 days later, transferred embryos. Half of the embryos were untreated controls, and the other half received 2,000 international units of human chorionic gonadotropin. And so on the next slide, I'll show you why we were doing this. These top two, these are cartoons of what the structures of these particular hormones look like. So LH and FSH are the classic pituitary gonadotropins. All these molecules have a common alpha subunit. The beta subunit is what confers binding specificity to the receptor and biological action. And the point I'm making here, human chorionic gonadotropin, the homology is about 80% with LH. So we can give it to a heifer or a cow, it'll act like LH, and it will cause an ovulation. And so what we're doing here, this would be a cartoon of the estrous cycle. On day 7, here I'm just showing on day 0, we've got an ovulation. That's at the end of a cycle, or let's say at the end of the protocol that I was showing you. And then 7 days later, we'll have a dominant follicle on that ovary. If we treat with an ovulatory stimulus, we will get a second corpus luteum, and then that will increase progesterone concentration. So the whole idea was that if we treat with HCG on day 7, that we would be able to increase progesterone concentrations and possibly have a effect on either pregnancies per ET or pregnancy loss. And in our study, there was no effect on fertility at day 32 or day 67. But what you'll notice here, and this was kind of an observation, this really wasn't part of our hypothesis, but the pregnancy loss for the control heifers, 22%, we dropped that by about 50% treating with HCG. So maybe when you're transferring fresh embryos, we can get a decrease in pregnancy loss, which is one of the big problems that we have with these IVP embryos. I'm just showing you this particular study by my colleague Milo Wiltbank. They did a much larger study here. Again, these are Holstein IVP fresh embryos, lots of embryos. They did something a little different. Rather than giving HCG on day 7, they gave GnRH on day 5 and transferred embryos. And you can see when they induced a accessory CL, they were able to drop pregnancy losses by about 50%. So I've just shown you 2 different studies that getting an accessory corpus luteum there, increasing progesterone after the time that we transfer these embryos, these fresh IVP embryos, appears to decrease pregnancy loss. So that's the background for this last study that I want to get into here. And again, this was a study that we did in a Jersey herd here in Wisconsin. So we had 2 different studies that we did here. So got a poll question number 3. What is the current value of a dairy beef crossbred calf? This number has fluctuated around quite a bit, so I'm interested in what people are going to say. I hear all kinds of things out there on the street.
All right, so we're looking to see what people are receiving for their dairy beef calves or what they're hearing out there for an average price. And we've got good answers. Give you a couple seconds if you didn't get your response in yet. Okay, we'll close the poll and we'll quickly go over these answers here. $200 was the answer from 15%, $400, 13%, $600, 31%, $800, 33%. That was the winner, and then $1,000, 8%.
Okay.
No.
Pretty much matches what I've heard out there. I mean, the problem with a question like this is a lot of people, when they're talk about the highest price they've ever heard. And so it's kind of interesting to hear. I figured it would be somewhere in the range that you talked about. So the point is, at this moment in time, and I'll stress that this is a moment in time because things are rapidly fluctuating with use of sexton beef semen and the value of these calves. For a number of reasons, the beef type animals are quite valuable. And so this is the study that we did. Now, this is a picture of a full blood IVF Angus calf out of this particular Jersey dam. What we did is we got embryos. They're commercial Angus oocytes that were collected at slaughter. IVF was conducted using 1 of 3 Angus sires selected for calving ease, and grade 1 stage 7 embryos were frozen for direct transfer. So this is different than the other 2 studies that I showed you. These are frozen IVP Angus embryos. So why do we want to do this? At the time that we started this study, which now would be a year and a half ago, they were getting, and these are actual costs that we got from the farm, they were getting about $10 for a Jersey bull calf. Obviously, this is why the Jersey folks are using a lot of sex semen. They want to avoid that low cost of producing those jerseys. If they used beef on jerseys, so Angus beef on a Jersey dam, they were getting calves that were worth about $250. And again, the Angus IVF calf at that time was $400. Now, we just did that survey. That number has gone up, right? $600, $800, so maybe double at this particular point in time. So that's why I think some of the Jersey farms are really interested in these Angus embryos. So we did a couple different studies, and our first study, and this is my graduate student who's actually taken a blood sample from this Jersey. So we use the same kind of design that I've shown you all along here. We synchronized recipients at first service using a double OVSync program, and rather than doing timed AI, we considered that last junior age day 0, and we transferred these embryos on day 8 later, because we assumed that they'd be ovulating around, so that'd be about the right time to transfer those embryos. Then we had a group of animals that were synchronized, essentially using 2 prostaglandin treatments 14 days apart. Now you have to catch those animals in estrus, and once they're in estrus, then we can transfer those embryos on day 7. And what we were doing is we were treating with 2,500 IU of HCG within each of these treatments, okay? So it's a 2x2 factorial, we would call this. We've got control and HCG treatment, we've got double OVSync, we got estrus detection. Notice we don't have a lot of cows. We actually had to stop this study for a few reasons that I'll talk about here in a few minutes. So one of the things that happened, you have to synchronize kind of when animals are going to get embryos with the days that an ET veterinarian, and this is the veterinarian that was working with us, Dr. Rick, and so we were transferring embryos off of this double OVSync here on Thursdays. So that's a big embryo day. 96% you could transfer embryos into those double OVSync. Notice these red bars. These are when the animals came into estrus off that estrus synchronization program. We could get a transfer veterinarian there on Thursday, okay, only on Thursdays and Fridays. So there's a lot of these animals that come into heat outside of those times. So you can just see that you're going to be much more efficient with recipients if you put them on more of an aggressive, like a double OVSync program than synchronizing an estrus. So that's just an illustration of one of the problems that we ran into. So if you look at the recipient utilization rate, it's 93% for the cows that were synchronized with the double OBSYNC program. In other words, of the cows that were put onto a double OBSYNC program, when the veterinarian goes to put the embryo in, they assess the corpus luteum. 93% of the double OBSYNC cows had a corpus luteum that was acceptable for a transfer. That's a very high number. Of all of the animals that were synchronized for an estrus, we were only able to put embryos in 50%. So you accumulate all the costs to synchronize all those cows to estrus, but because of the way that things were set up in this particular study, it was only 50% of the cows that we could transfer. Those numbers are not that unusual. So these are a few different studies. So this is utilization rate to a synchronized estrus from a study in 2011, 34.5. Timed embryo transfer study, 89%, which was very close to our 93. They were a little better, coming off of prostaglandin treatment with estrus at 69.2%. And this study was awfully low, 30% to a synchronized estrus. So again, this represents a huge cost for an embryo transfer program. You're just much more efficient when you can set cows up for a synchronized ovulation and transfer on the same day. And so the farm kind of realized that this inefficiency was happening, so we kind of had to stop this part of the study. But my graduate student put together this kind of partial budget. And you can see, here's our recipient utilization rate, 93 versus 50%. Here's the hormonal treatments. You can see everything that we included. But the big difference here is unutilized recipients. Big cost for unutilized recipients. You can see the cost for the embryos didn't different, the cost for the transfers didn't different. And then the efficiency of getting the animals pregnant was the other difference here. And you can see $349.48, the total cost per pregnancy for the double OBSYNC, $484 for the estrus. And so advantage here to the double OBSYNC program. And you know what I would say at the cost, the value of these Angus calves, it's very profitable to transfer them. And I would probably be deferring toward a more efficient type of a program with the double OBSYNC protocol. Okay, so just quickly to go through, we continued on with this experiment too. And what we did is we dropped the estrus part. We just synchronized cows with this double OBSYNC. Here's the last gene age. Day 8, we transferred. And again, we're randomizing. Almost 200 cows were non-treated controls, and almost 200 cows got treated with 2,500 IU of HCG. Recipient utilization rate in the second study in 415 cows, 93%, just exactly the same as the first one. We assessed ovulatory response to that HCG treatment, 89% ovulation, very high. We would estimate it be probably in the 90% range, so that's exactly what we expected. These are just graphs. I won't dwell on this too long, just showing you, if you look at this red bar, day 14, so this is 7 days after the transfer, you can see these are the control cows. They had about 7 nanograms per mil of progesterone. The HCG treated cows, 9.5. So this is exactly what we wanted to do with that HCG treatment, was to increase progesterone concentrations by 7 days after transfer. So this is just showing you that the treatment did what we thought it did, and it was very effective in doing that. Now we get to the data, which was a little disappointing. We had a day 26 preg check. This was based on pregnancy-associated glycoprotein test that was done early on day 26. So about half the animals had a signal that there was enough pregnancy-associated glycoproteins there to suggest that there was a pregnancy present. But you can see by day 33 and 61, this is the pregnancy losses that I talked about. And that might be expected with these frozen IVP embryos. So this is just a summary of the pregnancy loss from day 26 to 33, somewhere in the neighborhood of 20 to 25%, very similar to what the folks in Ireland showed. It decreases quite a bit after that. The embryos that are alive at this point seem to stay alive. And then this is the overall losses from 26 to 61. So just to summarize this particular part of the talk on IVP embryo transfer, and this is just a synthesis comments based on what I showed you. Treatment with HCG at embryo transfer may decrease pregnancy loss with fresh IVP embryos, but not frozen IVP embryos. That's kind of an idea that we're working with now. So whatever it is about freezing those embryos, we can't rescue dead embryos essentially by treating with HCG. Pregnancies per ET with frozen IVP embryos is less than that using conventional beef semen. And that's the two studies, study number 2 and study number 3. So remember, we were getting about 50% conception rate with beef semen after timed AI versus about 30% with IVP timed embryo transfer. But at current beef calf values, the calf values are so high that they overwhelm that difference. So this IVET with these Angus embryos in Jerseys can be profitable. And finally, synchronization of estrus for IVF-ET is not optimal. We realized it, the farm we worked with realized it. Recipient utilization is extremely low with synchronized estrus. You need multiple days of the week for transfers. There are some farms that in-house all of this. They create the embryos. They have people that can transfer. They could probably get around some of that particular problem, but it didn't happen the way that we did this particular study. And finally, one of the things that would help to get more IVF embryos transferred was we need more trained ET technicians. I think we're in a limiting number of technicians out there in the industry, so we need to get that particular number up. So with that, Abby, I have come to the end of my presentation. I think I stayed almost on time, and we can go ahead and open up the floor for a few questions.
Absolutely, you did great. Thank you, Dr. Fricke, for that presentation. It's always really interesting to hear some of the research that you and your team are doing at the University of Wisconsin-Madison, and I hope that our listeners were able to take some pointers there and maybe things that they can implement on their farms. I'd also like to, if you can move ahead one slide, Dr. Fricke.
Okay,
I'd also like to thank Cryoport Systems for sponsoring this webinar. If you'd like to learn more about their company, you can look them up online, and you can also take a look at the informational sheets they have that are at the end of the PDF of the slides. And again, you can find that by clicking on the handout section of that GoToWebinar control panel. If you'd like to view this webinar again, it will be ready and available on our website archive later this week. You'll be able to find it there. You just go to hordes.com and then click on the webinar tab. At that same location, you can find all of our past webinars that have been recorded, and you should be able to find a nice selection and a variety of topics if you peruse through that list. Move ahead one more slide, and I'd like to highlight our upcoming webinars. The next webinar will take place on Monday, October 9th at our normal time of noon Central, or October 14th, excuse me, at noon Central. And our speaker will be Cornell University's Jessica McCart, and she'll be talking about fresh cows and getting them off to a great start. And then in November, we'll have a presentation by Mike Hutchins and Mike Rankin, and they'll be talking about the harvest year and looking ahead at feed inventories for the winter and then going into 2025. So if either of those topics look interesting to you, we'll hope that you'll make plans to attend once again. Now we'll move on to the questions that have come in. Have you move ahead one slide, Paul, and then I will jump into these questions. The first one goes back to our poll question that was talking about the value of dairy beef calves. And this person is wondering when we should be selling these dairy beef calves, males or females, to get the best return on investment. They say they're getting some recommendations that they should be setting up some sort of growing facility and raising them to 500 pounds versus selling them as young calves. With the farms you're working with, Paul, do you have any recommendations or just comments on what you're seeing?
Yeah, Abby, this is a great question. I'll make comments and I'll just let everybody know this is not my area of expertise, marketing and all that kind of stuff. All I can comment on is what I see out there and some of the thoughts that I've had. And this goes along with the question, should I be using sexed beef semen to breed my animals? And so I'll use that to kind of answer this question. The only way you can recoup the cost and the reproductive drag using sexed beef semen is if you raise those animals up to 4 or 5 weights and sell them yourself. If you're selling day or week old crossbred or straight bred animals, I just don't think you capture the male versus female difference. So I guess the answer to the actual question would be, if you're only interested in selling day old or week old calves, probably not useful to use sex beef semen. You're gonna focus on your dairy operation. If you want to get into the business of feeding out animals, then you can start to think about using some other strategies, like maybe some sexed beef semen on your dairy animals. So I hope that kind of answers the question.
Thank you for that. The next question is in reference to synchronization, and this person is asking, is HCG different from GnRH? And if so, how?
Oh, yeah. Yeah, so I showed the one graph. So essentially, GnRH is a decapeptide that we give to cows. It's going to cause an LH surge, which is going to cause ovulation. So there's a cascade there. So during these synchronization protocols, when we treat with GnRH, we're using GnRH to cause an LH surge. We're using LH, then that LH causes actually the ovulation. Why don't we just give LH? Well, LH is a big molecule. It's glycosylated. It's hard to make. GnRH is small molecule. It's very cheap. It can be synthesized very easily. So that's the cascade: GnRH, LH, ovulation. Because HCG is similar in structure to LH, it's just like giving them LH. So you sidestep that GnRH part of that cascade. And the advantage to that is we can induce ovulations when progesterone is present. And again, this is a little bit more of a physiology answer, but when you give GnRH, when there's on day 7, there's a new corpus luteum there producing progesterone, you diminish the effectiveness of that GnRH treatment. So you might only get 60 to 70% ovulations with HCG on day, or with GnRH on day 7. If you give HCG on day 7, we got very close to 90% ovulation. So that's why we use that. And so it is a different molecule.
All right. Next question. What would be a good benchmark or reference parameter for fertility for heifers when using sex semen for first, second, and third service?
Yeah, great question. And again, my rule of thumb is to take whatever you're getting with conventional semen on those heifers. Let's say you're getting 60% conception rate with conventional semen. You would take 60% times 0.85, that's 85% of 60%. You're going to be very close to 52%. And so that mathematics works because, not everybody gets 60%. If you're at 50%, you take 50% times 0.85, and you're gonna get a very close approximation, I think, of what you get. Now, keep in mind, as a farmer, you influence fertility a lot. For example, you won't put expensive sex semen into an animal that you are not certain is in good estrus. So human behavior can influence fertility a lot. And I'm talking about the difference in like randomized controlled trials. But we did a large heifer study with sex semen, and conception rates were right in the 52% range with sex semen, and I thought that was pretty good.
Very good. Second part of that question is asking about good benchmarks for using sex semen at first service for first lactation cows. So any different recommendations or advice versus those heifers?
Yeah, and I'll reference back to the study we did in jerseys. When we inseminated jerseys with at first service with conventional beef semen off the double ov sink, it was 60%. When we inseminated those jerseys coming off the double ov sink with sexed jersey semen, it was 52%. And 52 is 85% of 60. So that math works, right? And so again, that's kind of the mathematics I use to calculate that. But again, keep in mind those populations of jerseys that were submitted to beef semen versus sex semen in that herd, they're not the same animals. They're using sex semen on a very specific group of animals, probably based on the genomics and the genomic value of those particular animals. So no one has ever allowed me to randomize animals to get sex or beef semen, which is the kind of a study that you'd have to do to actually get the number that you're asking about.
Mhm. And we have a somewhat related question here, and we have listeners from all around the world. So this person
Sure.
happens to be from Pakistan, and they're just curious, like they're not seeing the conception rates they would like from sex semen, and they're wondering how we are getting better conception rates here in the U.S. versus, you know, maybe where they are. So again, any tips for improving the conception rate when using sex semen?
I do have a tip now. So one of the studies I didn't show that we did, it depends. So timing of insemination with sex semen is more important. Timing of insemination relative to estrus or ovulation is more important with sex semen than it is for conventional semen. Sex semen is a very different population of sperm. They have shorter lifespan, fertile lifespan in the female reproductive tract. And so to support that comment, what we had done is we had non-lactating Holstein heifers that were either tail chalked once a day, and then they just walked and chalked once a day. So they'd go through any heifers that had rubbed tail chalk were inseminated with sex semen. We compared that to heifers that were submitted to a timed insemination protocol in which we controlled the timing of ovulation much better, okay? And it was a 7 percentage point advantage for using sex semen on those heifers to a timed AI versus once daily estrus detection. So I don't know how they're doing the breeding at this particular farm in Pakistan, but and once daily breeding doesn't work so well. If you go to twice daily breeding to estrus, that helps. We have another study in heifers that would show that. You can also, if you're doing timed AI, you can choose the wrong time to breed. So we always recommend keeping with the same schedule where we're about, we're breeding 16 hours after the last GnRH treatment of, say, a double ovsync protocol. So there are a number of factors that affect fertility to sex semen.
What are the current theories on the causes for large birth weights in the IVP embryo calves?
Yeah, so that's a great question. I don't know if I need to go back and review the whole story. That there are a certain percentage of those calves that will have increased birth weight. It's really not the large calf syndrome that we used to see when they were using fetal calf serum in the culture media. So it's a different problem. There was a session at the latest IETS meeting kind of on this large calf thing. There's a few of them that are large. It's not a big percent. I think in our study it was maybe 10% of them. And there was no C-sections done. There were just some animals needed assistance at calving compared to others. But I don't think we know everything that we need to know to answer that particular question at this time. It could be epigenetic. It could be, methylation patterns in the DNA. It's just really hard to tell what's going on.
Mm-hmm. Switching gears just a little bit, what are you seeing for beef conception rates compared to conventional dairy semen in heifers and cows?
Yeah, that's a great question. Early on, when people started using beef semen, I think it caught the AI companies a little short on beef semen. I think people were emptying out tanks just trying to get any kind of beef semen they could find. And so there was this idea that beef semen was not as good as, say, dairy semen. Dairy bulls have been selected a long time for fertility. But the AI companies have done a commendable job catching up with this trend, and now they're doing very intensive selection, and we have really good sires on the beef side for use in dairy cows. And so in our study in those jerseys, 60%, we were getting 60% conception rates at the first preg check on day 34 with beef semen on those lactating Jersey cows. So I felt that was a very, very good number.
Besides Angus, what beef breeds are currently being recommended to use on dairy cows or heifers?
Yeah, well, again, I'm probably in over my head on answering that question. I can just show you in our part of the world, which is kind of that Great Lakes region in the Northeast, the Angus sire is by far and away the one that is winning the race. I have been to the southwest part of the United States, and they'd use more blonde breeds, Charolais, for example. Um, so I think it depends on where you are. It depends on who you are marketing those calves to. And so a lot of people that forward contract these calves, the buyers will say, as long as you use this set of bulls, whatever breed it may be, then we'll buy your calves from them. So I think it depends on where you are in the country and what people are looking for in those carcasses.
Mhm. Do you know of any dairy producers who are milking Holstein Angus crosses? And if so, what kind of production do those cows have?
Nope, don't know anybody that's milking a Holstein Angus crosses. I don't think you want to do that. That's why we're using sex semen on our best animals, just is to produce the replacements that you would milk in your herd. So those beef cross dairy beef crosses are getting sold usually within a week if they're not fed out and taken to slaughter.
Hmm. Yeah, I'm not familiar with any
Yep.
either.
Nope.
This person is saying that in research they've seen, it's recommended to use GnRH or HCG at day 9 for accessory corpus luteum, where you're using it on day 7. Why
Yeah.
that difference?
Yeah. Well, one of the reasons we did it on day 7 is because that's the day that you've restrained the animals to do the embryo transfer. So it was a matter of being easy. You could induce an ovulation on day 9, certainly, and maybe there would be differences in fertility. I'm not aware of studies that can have compared when that accessory CL is formed uh, in those particular studies, but it's an interesting comment. And we did it day 7. Um, it's all going to depend on when you want progesterone to be there post transfer to perhaps affect the embryo. But as I showed you, I mean, we've got blood samples in that study showing that we were able to increase progesterone by 2.5 nanograms per mil by day 14. So that was a pretty good increase in progesterone. So
The studies you shared utilized synchronization. I have a person wondering if you receive any pushback or just in general in the industry pushback concerning hormone injections in lactating dairy cows.
oh yeah, I mean, people talk about this all the time. Um, it's very logical that you would be able to use reproductive hormones to manipulate the reproductive cycle, just because that's the way we control the reproductive cycle is through hormones. These hormones are short acting and they're not there for very long. They don't get into the meat and the milk. They're completely safe for the animal and, for humans that are consuming the milk and those kinds of things. So there is a perception that some consumers don't like hormones, but the programs are very successful. The efficiencies are very high when using the programs from a conception rate standpoint. When I was doing my sabbatical in Ireland in 2014, there was some reluctance to use fertility programs. Now the difference is in Ireland, those Irish Friesian cows give about a third of the milk that our North American Holsteins do. So they don't have the problem that I was talking about with that liver metabolism. So use of a synchronization protocol in their lactating dairy cows is not as big of a bang for their buck as it is in our cows. And I showed we get about a 10 percentage point increase in fertility. Now, having said that, they are using a lot of sex semen in heifers in Ireland. And what they find is that it's much more easy to implement on farms when you synchronize those heifers. And so, because they're pasture based and heifers are kind of out of sight, out of mind. So I think there's a lot of advantages to using these synchronization programs from a fertility standpoint. And the last thing I would say, I talked about the high fertility cycle. Getting cows pregnant in a timely fashion, you end up with much healthier cows. So I've argued that these protocols are actually good for the cows. I mean, we can decrease a lot of periparturient problems with cows that are losing body condition score and so on and so forth. That's a little bit of a different talk, but I do understand the question. I get the question often.
Yeah, thank you for addressing that. Can you confirm, is HCG approved for use in lactating dairy cows?
Yeah, it's a Merck product, so it is approved for use in lactating dairy cows.
All right. And here we have kind of a more economic question. Do you know, has anyone looked at the real cost when considering a pregnancy? If only farms have a 30–40% pregnancy rate, what is the value of those additional days open, resetting up open cows? You know, what is the real cost of each live calf?
Yeah, that's a good question. We haven't really looked at it in that way. Those economics are a little like you're saying. Those economics are a lot more complex. What we did in our study is cows, for example, those recipients that were not utilized were resynchronized and inseminated. And so, yeah, you're going to lose some days open there. It all depends on when those days open occur. A day open early from day, say, 60 to 80 is not very expensive, but as they get further along in lactation, the cost of a day open can actually increase a lot. So we haven't gone to the extent to calculate that, but all those things are factors that you have to consider if you're going to go into the embryo transfer business. So it's a really good question.
All right, thank you, Paul. With that, we have gone through all our questions and we'll conclude this section of the webinar. Once again, I'd like to thank Dr. Paul Fricke from the University of Wisconsin-Madison for sharing his research on reproductive technologies with us during this webinar. I'd also like to thank Cryosport Systems for their support of this webinar. It is greatly appreciated. And of course, I'd like to thank all of you in the audience. We really appreciate the time you take to join us for each of these webinars. I hope that you were able to take away some useful information that you can utilize on your dairy or the dairy farms that you work with. So again, thank you for taking your time to be with us for this last hour. Until next time, goodbye from the team here at Hordes Dairymen, and we look forward to hopefully seeing you on a future webinar.